My name is AJ Allport, and my presentation today is on talking about the infrastructure of buildings and how we can improve on them. But with that, we're using an example of earthquakes in residential buildings. We all know that all the big buildings in the world are earthquake resistant, which so and so calls them. They will be able to withstand up to normally a 7.0 earthquake due to the technology that is under the building. Since the beginning of time, humans have been trying to make the safest buildings possible for all possible situations: fires, earthquakes. Through our 14 engineering grand problems, we have the making our infrastructures stronger, which for earthquakes needs to be one of the most important things so the building does not collapse under the pressure from the earthquake. The world's first earthquake-proof building actually came into effect in 2016 in Kengo-kuma, which is in Japan. It is an office building, which is a building that they have ropes on every side, or steel rope on every side, which makes the building sway, but not sway so much that the infrastructure of the building will start to crumble under itself. These have been they have been made under a mandatory expectation since 1933, since the Long Beach earthquake. So in doing that, they want us to use more steel reinforcements in the building to make the infrastructure stronger. To start off, we're going to talk about with what causes an earthquake. An earthquake is a cause when two pieces of mass or earth slip by each other, causing a seismic wave that shakes the ground in either direction. And after that, it could range anywhere from a 3 to a 10 on the Richter scale. Most of them are in between the 4 and the 7 range normally, but then there are aftershocks. The aftershocks can cause more damage when the building's at its weakest point. So to combat those weakest points, we use these. We have cross bracing, which reinforces the walls using beams using the X pattern. We also have these shock absorbers under the buildings, which we could put into place under residential buildings that will help the swaying of the building instead of making the building crumble under the pressure. And then the shear walls. The shear walls make the rocking movement become less and less during the earthquakes. And from 1960 till now, there has been a rise in earthquakes recently. This graph shows 1900 to 1910, we had a huge spike in earthquakes. Then it started to go down to 1930 and 1940. Then back up in 1950. Then 1970, 1980, 1990 were at its weakest points. But now getting into the 2000 and 2010s, due to the earth, the plates have been shifting more, and the earthquakes have been steadily going up, which is causing more residential areas to see destruction because of the earthquakes. Look at 2007 earthquake of Fukushima, which caused earthquake, a tidal wave, and a nuclear reactor because of the earthquake to explode. So if we use the new technology that we have in the bigger buildings, the shear walls, the cross braces, the steel beams going through everything, and the shock absorbers under it, this can help our residential buildings be more stable, be safer, and cause less casualties during a big event like an earthquake. Even it will help during fires because the steel beams won't melt. But all in all, the earthquakes have a huge effect on smaller buildings, smaller populations. The big buildings are made to withstand those. These smaller buildings aren't made to withstand those, which can cause massive destruction during these times. So I say we use the technology, but on a smaller scale in these residential buildings, like apartment buildings, some houses, some office buildings, even stuff like that, which will make our buildings more safer, and it will add less destruction to it, which will keep our citizens and our city safe during times like this.